All right, so today we're going to do a video on implicit differentiation. So all that means is I can now take the derivative of a y. So you can see up here, before we used to write y prime, that's really because the derivative of y is 1 dy over dx. And we don't write anything behind the x because the derivative of 2x, or of x squared, would be 2x, dx over dx, and dx over dx is just 1. So now we're going to use all the same rules, but take the derivative with respect to y. So a derivative of y squared would be a 2y with a dy over dx. That means you took the derivative of y with respect to an x. Derivative of x is still 1. So to solve this, we're going to do dy over dx equals 1 over 2y. So same here. This would be a 2x plus 2y, but you took the derivative of y with respect to x. So you put that behind it. Derivative of 25 is 0. Subtract over your 2x, and then divide by your 2y. So dy over dx equals negative x over y. So derivative here, tan of x would be 1. Derivative tangent y would be secant squared y, dy over dx. Divide that over, so get 1 over secant squared equals dy over dx. That's the same thing as flipping that to the top to making it cosine y. So right here would be a 2 dy over dx. Derivative of that is a 2x. Derivative of that is a cosine y dy over dx. So this time I got to put the dy over dx is on the same side so that I can factor out the dy over dx. So subtract that over first. And now I'm going to factor out the dy over dx so that I can isolate it. So you have 2 minus cosine of y equals 2x. And then divide, that's times here, not equals. And then divide that over. So the derivative is 2x, that's a y, 2x over 2 minus cosine y. This one here, I would have just multiplied that over to make it x cubed plus xy equals x minus y. And then this becomes a product rule. So this here would be 3x squared, product rule. Leave the first alone times the derivative of your second, plus second alone, derivative of your first. Right side, derivative of 1 minus dy over dx. Put the dy dx on the same side, so I'm going to move the 1 here, that over there. So I get 3x squared plus y minus 1 goes negative x dy over dx minus dy over dx. Now you can factor out this dy over dx on this side, and you're left with negative x minus 1, and then you would divide that over to the other side. So you have negative here. So that's the derivative. I'm going to show one like number 7 here. So take the derivative of this is a 1 plus derivative of this would be a secant squared of xy times the derivative of that. So that's the chain rule right there. So leave the first alone times the derivative of the second plus second alone times the derivative of the first. All this equals 0 on that side. Sorry, I dropped that part. It does equal 0. Sorry if the screen's locking up on you. It looks like it's locking up on me here. So this right here is one term, and it has to get multiplied to both the x and to the y. So you end up with 1 plus an x secant squared of xy, dy over dx is still in there, plus y times that term. So move this to the other side. So you get negative x secant squared of xy dy over dx equals 1 plus y secant squared of xy. Now divide by this term and you're done. And you can't simplify because you're adding on top and stuff. So you would just leave it really like this term. I guess you could divide here and get some stuff, but we're just going to leave it like this right now. That would be the way the AP exam would write it. Now for day 2, apparently these notes don't have the day 2 on the back. So yours probably has some notes on the back. I'm just going to go ahead and make up my own example real quick to show the other derivative. So to take a second derivative, this is the one we had on the front, and the derivative was negative x over y. So I know the first derivative of this is negative x over y. So to take a second derivative, we're just going to say it's the second derivative with respect to x again, and we're going to do a quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. So that gives me negative y plus x dy over dx over y squared. Now I have to plug in what dy over dx equals right there. So it's negative plus x, and that would be negative x over y squared. This, you now need to get a common denominator. So multiply this side by a y over y. So the tops would be common. That's really a negative there. So now the bottoms are the same, so add your tops there. So negative x, I guess I could have just written minus. Flip and multiply this, so it becomes y cubed on the bottom. So the second derivative, I don't know why I keep putting plus and negative there. All right, so the idea is that whenever you see this in a second derivative, you must put what the first derivative equals there. So anytime you see a dy over dx in the second derivative, you plug what the first derivative is.